Hi, good afternoon, everyone. So today we'll try to understand about the first concept, the transient response of a series RL circuit with a DC input. Excitation is nothing but input, where response is called output. So these are a little bit complicated to analyze. This convert into a simplest form. Excitation means giving input. Response means taking the output is called response. So these are the two technical terms. Let's try to understand what is meant by a transient. So generally in an electrical circuit, let's try to understand the definition in such a way that it will be useful to analyze. So transient means when a network is switched from one condition to another condition by applying voltage. Okay. So here how the transient is situated is, so here we are applying a voltage of V volts, and the switch was available at 0 minus and switch has been shifted to point A. Okay, so therefore the switch has been moved from K position to A position at t equal to 0 plus. Okay, so switch was there at 0 minus at K and it has been shifted to A, and the voltage is applied to the RL network. So then this condition of changing of switching or changing the application of voltage to the RL elements is called transient. Response means output. So you have to find out this output. Let's try to understand in brief what is meant by transient. Okay, so when a network is switched from one condition to another condition, so previously it was not given the voltage. Now after switching at t equal to 0 plus, the voltage is applied to the RL network. So this is called transient. So whenever the switching happen, now the inductor starts charging the energy. Okay. So we'll discuss in detail how the inductor doesn't allows the. For example, we have the voltage across the inductor V equal to L di by dt. So generally, inductor do not allow sudden change in current. Okay. For example, the current is flowing like this. If the source becomes zero, the inductor will try to discharge and it will try to maintain the current. Sir, how to understand? So this very lot to discuss, but my focus today is only on series RL circuit. If it is required, we will discuss how why an inductor doesn't allow sudden change in current, why a capacitor. So we have the current across a capacitor, current I is equal to C dV by dt. So here also capacitor doesn't allow sudden change in voltage. Okay, once the it's like if inductor is charged with some sort of current. If suddenly the voltage becomes zero, it will try to discharge and it will try to maintain that same current. So this is how we generally call the inductor doesn't allow the sudden change in current. Capacitor doesn't allow the sudden change in voltage. So this we'll discuss later. For time being, let's try to understand what is meant by a transient. Okay. So now coming to the concept of a transient. So let's take a simple example to understand a transient. Okay. So transients are nothing like for example, you are moving on a smooth road. Okay, so you are moving on a smooth road. Okay, so you can see some, we have some sort of road crossing, or you have some sort of bumps. Okay, or now when you are traveling on this on a bike, you are traveling, so on a two wheeler or four wheeler you are traveling, so whenever you are traveling on this road, you can see here you got an speed breaker. So suddenly you will be applying a brake here and your position change. So this is like for some time, so this time is called transient time. So before you are in steady state and you apply the brake and suddenly jumped from this position to this position, and again you started traveling in a steady state. So before you were in steady state, and after that also you were in steady state, but in the duration of the speed breaker, so there is nothing but your speed breaker. So in the duration of a speed breaker, you were in transient condition. So I can say that transients will not be present for longer time. They present for an shorter time, which is nothing but four times the time constant. So just try to understand. If I take the time constant is 1 second, so maximum it will be available for 4 seconds only. So just like here also previously, the network is not given any supply. Suddenly we switch it from position A to position K to position A. Automatic the voltage is applied to this resistor and inductor. This is the change of voltage, or suddenly a voltage source is energized. So this is called transient. So for this we have to find out the output of this network. Okay, so hope you are able to understand. So for example, sir, how to understand the transient? Okay, so for example, if I am trying to draw the current diagram, this is nothing but the current across the inductor and versus the time. So suddenly what happened? I have been given the voltage and the inductor and resistor are there. The current flows across the inductor and resistor, and the inductor starts charging. So now the inductor is charging. Suddenly I had given the voltage. So this time I am going to call as transient state. So here still it is in which state? Transient state. So after some time the system comes to which state? Steady state. So now the waveform is in steady state. So this maximum value current I is equal to V by R. This very simple formula. Then you can calculate. For example, at steady state it tries to maintain 10 amperes, but slowly it try to charge 1 ampere, 2 ampere, 3 ampere, 4 ampere, 5 ampere, 6 ampere, 7, 8, 9, 10. So after the transient time the inductor is 100% charged. So again what will happen, the inductor will try to discharge from one steady state to try to come to the once again to the one more steady state. So this period once again I'm going to call a transient state, and once again this comes to a steady state. So the final states are called as a steady state. So these are called the steady state. So every time when you give the voltage, the inductor starts charging and it's try to move from transient state to steady state. After achieving the steady state, for example, you remove the supply. So the inductor try to discharge. Therefore, the inductor charges as well as discharges depending upon the availability of supply. So this is what the behavior of an inductor in all the two positions. Okay. So so here the time taken by the inductor, this time is called as a transient time, and the time taken is 4 seconds or 4 times the time constant. Here also the time taken by to get it settled is nothing but the transient state is around 4 seconds. Once again the I mean 5 times the time constant, it comes to steady state. So this is how I can say a transient. Okay, you can understand the transient in one more way. So here we are traveling on a road, still we are in a steady state. You apply the brake here. When you apply the brake, your vehicle will oscillate, or you can see there is some sort of sudden change in its position, or in its change in direction, or change in its position, or the vehicle speed will decrease. All this decrement is nothing but will occur only in this speed breaker duration. After you cross it and still it have some sort of reduced speed, and once again you start increasing the acceleration, the vehicle will try to continue. So this is called the transient response. Now let us try to understand how these transients work out. Okay, let's try to solve this transient behavior of an resistor and inductor. So already I told we have been these sort of sources are called voltage is given at t equal to 0 plus, and it is connected to the point A, and the current flows across the resistor, and the inductor will start storing the voltage. Okay, so this is how we have the concept of so of transient response. Now let's try to derive the expression for this current. Okay, so let's try to apply the concept of application. Okay, so when you try to apply the, let's try to apply Kirchhoff's voltage law. So you can see here how to apply the Kirchhoff's voltage law. So we applied some, it's very simple circuit. So you have a voltage source driven, and you have a resistor, and you have an inductor. So voltage V is applied, this is R and this is L. Okay, so this is positive negative positive negative, and this is a voltage V. Now let's try to understand some current of I of t is flowing, which is these are connected in series, therefore the current is same. So when you apply the voltage, then we are going to get the voltage. So current is leaving, or the leaving polarity of the voltage, plus V minus I of t into R, and the current is leaving, or the leaving polarity, or the voltage across the inductor. It's already discussed. The leaving polarity is minus V equal to L di by dt. So we need to find the expression of I of t. Okay, so this is nothing but di by dt. So I'm going to write down d. I am directly writing as d of t. Okay, I of t. So now what we are going to do is we want to arrange this in such a format. Okay, so try to express v is equal to I into r plus l di by dt. Okay, so now I want to express this in terms of I of t. So what I'm going to do is I'm bringing this 1 by rs, I mean rs common. So v is equal to r into, so when you take rs common, so this is nothing but r of t plus l by r into d I of t divided by dt. So now you got this value. So I'm bringing this r to the denominator and I'm expressing v by r is equal to I of t plus l by r into d by dt of I of t. So here I want to express in an a standard format. So here I'm going to write down this as a v by r minus I of t is equal to l by r into d by dt of I of t. So here we need to express this in one format in such a way that so you see here this term completely I'm shifting to this side. Okay, so when I'm going to perform the integration like this, so you can see here, so this can be expressed as so we need to express in the form of an integral we need to get. So we have the formula integral of dx divided by a minus x is nothing but minus ln a minus x. So this is the formula we need to arrange it. So in order to arrange it, so what I'm going to do is so here I'm going to retune it. So this I'm going to express in the form of d I of t divided by, so this term I'm bringing down, v by r minus I of t is equal to, so this term will come to this numerator side. Okay, so that is indicated as a r by L into dt. So just I'm moving this term to this side and this term to the denominator side. So this is a numerator and comes to here is nothing but r by L into dt. So this complete term will come now. Sir, why you express in this form? Why? Because I want to express in this form. So dx divided by a minus x. So here my intention is finding out I of t. So here you have a differentiation. To nullify this differentiation, I am going to perform integration on both sides. If I perform the integration on both sides, differentiation, integration get nullified, then I can express I of t. Okay, so therefore, integral of dx into a minus x, if you perform differentiation and integration get cancelled, then you will get the value of current. So this is minus ln a minus x. What is a value? A is v minus r minus I of t is equal to, so here r by l is an constant, r by l differentiation integration get cancelled, r by l into t plus we have to write down with a constant where k dash, this is called arbitrary constant, where k dash is called arbitrary constant. Now we need to find out this k dash. So how to find the k dash? So this is very simple. So how now we need to find out the value of k dash. Then only can find out the value of I of t. So k dash is nothing but the arbitrary constant. So how to find the arbitrary constant? So already we told that the case of this inductor. So here you can see here. So initially the switch was in position K, and after a t equal 0 plus it has been moved to A point. So when it was in K position, the total current or the current I of t is 0. Okay, so when it is in position here only, for example, the switch, so here at this position, so it was only in position K, and you can see here now it is not connected to source. Since it's not connected to source, automatically the voltage is not applied, therefore the current in the network is 0. So is the condition at t equal to 0 minus. So the initial condition of the current, okay, so the initial current at t equal to 0 minus is the current I of t equal to 0. Okay, now you substitute this in this expression, so minus ln v by r minus what is the current at t equal 0 minus 0, that is equal to r by l into t equal to 0 minus is 0 plus k dash. So when you perform it, so here I am going to get k dash is equal to minus ln v by r. So this is the arbitrary constant. Now substitute this arbitrary constant in this expression. Okay. So when you substitute this arbitrary constant, our intention is to find the response current I of t. So let's try to substitute here. So when you substitute here, you are going to get minus ln v by r minus I of t is equal to r by l into t, and what is the k dash you obtain? So this is nothing but minus ln v by r. So this plus and minus will be written as a directly minus. It's nothing but minus ln v by r. So this are in negative terms. Let's try to move them into one side. So this is you can write down, when you move it, you can write down this as a, so when you try to move this is a minus r by l into t is equal to minus ln v by r plus ln v by r minus I of t. So this is ln a minus ln b. So when you can write down ln a minus ln b as this term remains same. So you can write down it as ln a by b, which is nothing but v by r minus I of t divided by v by r. Okay, so when you write down this one, you can see here, when note this, so we require the expression of I. When now the ln come this side, we can write down this as u to the power minus r by l into t is equal to, so we can write down it as v by r minus I of t divided by v by r. So we require the expression of I of t. So what I can do is, so just v by r into e to the power minus r by l into t is equal to, you can write down this as v by r minus I of t. So I require the expression of I of t. So I am bringing this I of t this side. So I of t is equal to v by r minus v by r e to the power minus r by l into t. So further I am simplifying this, so I can write down as I of t is equal to v by r, I am taking common, this is nothing but 1 minus e to the power minus r by l into t. And now I want to plot this curve, so I can say this is called the expression for current, is called the expression for current for a series driven RL circuit. So this is nothing but, you can see here, I can say how to draw it, you can understand clearly. So this expression we can understand. So this is V by R, okay, where I of t also I can write down it as this is a sum of steady state current plus transient state, okay. So V by R is nothing but the steady state value. So for example, V by R, for example, it is 10 amperes. So it will reach this 10 amperes, but it is in the form of minus V by R in e to the power is nothing but exponential rise. Okay, so and it reaches the steady state value of, so it consists of two parts. This part is called steady state part, and this part is called transient state part. So when you try to draw the graph, then you can understand better. So when you try to draw the graph of this curve I of t, you can see this graph. So this is the current across the RL circuit under the transient response. Let's try to substitute at, so now we are going to define the time constant also. At t equal to tau, what happened? At t equal to 2 tau, what will happen? At t equal to 4 tau, what will happen? At t equal to 6 tau, what it will happen? So you can see here, at t equal to tau, I of t is equal to v minus r into 1 minus e to the power minus, so you can write down this tau as t by tau. So now t is how much? Tau. So tau will cancel, so 1 minus e to the power minus 1, so this is approximately 0.632 I. Okay, so this also you can write down it as v by r into 1 minus e to the power minus t by tau, where tau is called the time constant, L by R, where L is nothing but the inductance, where R is nothing but the resistance. So this is how we can express. So that's how in this t I am substituting as t equal to tau, and it is giving a 63 percentage. Similarly, I am substituting I of t is equal to v by r into 1 minus e to the power. Now t is how much? 2 tau. 2 tau divided by tau. Tau will cancel. 1 minus e to the power minus 2. This will give you an magnitude of 0.86 I. And similarly, substitute I of t is equal to v by r into 1 minus e to the power 4 tau divided by tau. Tau will cancel. When you perform in the calculator, you are going to get this as at 4 tau, you are going to get as 0.98, 0.98. This v by r can be written as I. So similarly, at I of t is equal to v by r 1 minus e to the power 6 tau divided by tau. Tau will get cancelled, and this will give you the value of 0.99 I. You can see here at t equal to tau. So this is t equal to tau. So is the waveform is in the form of, what is the waveform? The nature of the waveform. So this is exponential rise. So this will be like this. This is exponentially rising, where from 0 at tau it reaches 60 percentage. Okay. So this reaches how much percentage? So 0.60. I mean 0.63%. I mean 63 percentage. So t equal to tau. So t equal to 2 tau. So at t equal to 2 tau, it may reach 0.86 of I. At t equal to 4 tau, t equal to 4 tau, it reaches the maximum current. So this maximum current we may call it as 1 ampere. So this is the 4 tau. And after 6 tau it comes to steady state. So this is called steady state. So at steady state it is maintaining around 1 ampere. So this you can redraw it like this by rejoining. So this is the transient response. Okay, so this is called the transient response. So this we can call this 1 ampere is called steady state current. So then will take it as a 100 percentage. This is 63 percentage. This is 86 percentage. So after 4 times the time constant, the current will be in which state? Steady state. So this period, the time taken by this waveform, this period is called as a transient state. This is called transient state. And after this 4 times the time constant, this will be in steady state. At steady state, what is the magnitude of the current? 100 amperes. So slowly, the here what you have to understand is slowly the inductor is charging in the which period? Transient period. And the inductor comes to which state? Steady state. Under which source of excitation is whenever it is excited with and voltage of V volts. Now it's very simple to understand. The inductor has been slowly charged and it has reached the steady state. So this is what the how the inductor is charged. Okay. So here this how an inductor is now completely charged. What this inductor will do in the second case is let us try to see here. What it will try to do is so now it is in which position? A position. So from A it will try to move to which position? B position. Then automatically the inductor which was charged will try to discharge now. So which is already charged, now it will try to discharge. So now let's try to draw the diagram.